A team of geneticists is staring at a screen in Dublin, and none of them can explain what they're looking at. A 4,000-year-old skeleton from a farming village, a medieval graveyard on the edge of the Atlantic, a living volunteer who walked into a lab last spring and spat into a tube. 3 different centuries, 3 different bodies, one matching signature running through all of them. And when the team widens the comparison to every population across Europe, from the fjords of Norway to the hills of Anatolia, only one region on the entire continent lines up close enough to explain it. Before we tell you which one, you need to understand something strange. The Irish have been telling a story about exactly this place for over 1,000 years. Nobody believed them, not seriously. It was filed away as folklore, the kind of thing monks wrote down to make a small island sound important. Now the genome data is sitting on the table, and it is starting to look like the old story was never entirely wrong. This is not speculation dressed up as science. The findings come out of Trinity College Dublin, out of the Royal College of Surgeons in Ireland, and out of published peer-reviewed genetics journals including Nature, PNAS, and the American Journal of Human Genetics. The lead figures here are real, working scientists. Dan Bradley, professor of population genetics at Trinity College Dublin, has spent more than 2 decades sequencing ancient Irish remains. Laura Cassidy, also at Trinity, has authored some of the most cited ancient DNA papers to come out of the British Isles in the last 10 years. Giampiero Cavalieri at the Royal College of Surgeons in Ireland led the Irish DNA Atlas project, a study that sequenced thousands of modern Irish genomes and cross-referenced them against ancestry databases spanning the entire European continent. This isn't a hobbyist ancestry test bought online. This is laboratory-grade, journal-published, replicated science, and it keeps landing on the same answer. The Irish DNA Atlas alone drew on more than 1,000 modern volunteers, each one selected specifically because all 4 of their grandparents were born within a tight geographic radius of one another. A deliberate design choice meant to strip out the noise of 20th century migration and get as close as possible to a genuine regional signal. Those modern genomes were then run against reference panels covering essentially the entire European continent, along with a growing library of ancient DNA extracted from burial sites, some of it thousands of years old, sequenced using techniques that didn't exist even 15 years ago. This is the kind of study that takes years to complete and gets picked apart by other labs before anyone treats it as settled. And it has been picked apart repeatedly, and it has held up. But before we get to that answer, it's worth walking through what most people already believe about Irish ancestry, because almost none of it survives contact with the actual data. The first theory is the one you'll hear in almost any pub in Dublin or Cork. The Irish are Celts, plain and simple, descended from Iron Age tribes that swept across Europe from Central Europe, from the Hallstatt and Latane cultures in what is now Austria and eastern France, bringing their language and their culture with them into Ireland around 2,500 years ago. It's a good story. It explains the shared Celtic languages across Ireland, Scotland, Wales, and Brittany, and it gives Irish identity a clean, dramatic origin point. The problem is, the genetics don't cooperate. When researchers look for a large-scale population replacement in Ireland around the Iron Age, the time frame when the Hallstatt and Latane cultures were expanding, they find almost nothing. The Irish gene pool from that period looks remarkably continuous with what came before it. Whatever happened during the so-called Celtic expansion, it left behind language and material culture, but it did not leave behind a fresh wave of DNA. Something else was already there and had been there for a very long time. The second theory is the Viking one, and it has a much stronger foundation, at least locally. Norse raiders and settlers absolutely did arrive in Ireland, starting in the late 8th century, and they founded cities that still exist today, including Dublin itself. Modern Irish people, especially along the eastern coast, do carry a real and measurable amount of Scandinavian ancestry. But when the Irish DNA Atlas team quantified it, the Norse contribution came out small, typically in the low single-digit percentages for most of the country, concentrated heavily around the old Viking port towns rather than spread evenly across the island. It's real. It's just not the main story. It's a late chapter layered on top of something far older and far larger. The third theory is the quietest one, and in some ways the hardest to dislodge, because it isn't even really a theory so much as an assumption, that the Irish are simply the original unbroken indigenous population of the British Isles, sitting where they have always sat since the ice retreated, largely undisturbed by outside migration. This is the version of Irish ancestry that treats native as meaning there from the very beginning, with nothing major changing since. It's a comforting idea. It's also, according to the ancient genomes, almost the opposite of what actually happened. Ireland's population was not stable and undisturbed. At one specific point in prehistory, it underwent one of the most dramatic, near-total genetic turnovers documented anywhere in ancient European DNA. 90% of the Irish gene pool that existed before that moment did not survive it. 90%. That is not a gradual shift. That is closer to a replacement, so none of the three familiar stories fully holds up. The Celtic invasion story explains language, but not DNA. The Viking story is real, but small. And the always been here story collapses the moment you look at what happened roughly 4,500 years ago. None of them reach far enough back, and none of them account for the signal the researchers are actually seeing. To understand what does, you have to go back to the single most disruptive event in the entire genetic history of Ireland. And to do that, you first need an analogy for what ancestry-informative DNA is even measuring. Think of a population's genome the way you'd think of a city's accent. An accent isn't one single sound, it's a blend, a layered pattern built up from waves of people who moved through or settled in a place over centuries, each wave leaving a trace that gets folded into what comes after. A geneticist comparing two populations' DNA is doing something similar to a linguist comparing two accents, not listening for one identical word, but measuring how closely the whole pattern, the underlying structure, lines up. When Irish DNA is compared against, say, Norwegian DNA, the accent doesn't match well. When it's compared against most of England, there's overlap, but it's partial, muddied by centuries of separate history. What the researchers were looking for was a population somewhere on the map, whose genetic accent was close enough to Irish DNA that the resemblance couldn't be coincidence. And they found it. Not in Northern Europe, not in Central Europe. On the Atlantic coast of Iberia, concentrated most strongly in the Basque country and parts of northern Spain and Portugal. Here's the part that actually explains why. Around 4,500 years ago, a new archaeological culture began spreading across Western Europe, identifiable by a distinctive style of pottery, bell-shaped drinking vessels found in graves from Iberia, all the way to the British Isles. Archaeologists call it the bell beaker culture. For a long time, nobody was sure whether the bell beaker phenomenon spread as an idea, a fashion, a trade network passed from group to group, or whether it spread because actual people were moving. Ancient DNA settled the question, and the answer was people, when Laura Cassidy and Dan Bradley's team at Trinity College Dublin sequenced genomes from Irish sites dating to this period. Published in the Proceedings of the National Academy of Sciences, they found that the population living in Ireland after the bell beaker arrival was genetically almost unrecognizable compared to the population living there before it. In the next part of this, we go straight into what that turnover actually looked like at the molecular level, because the number involved is the kind that's easy to say and hard to actually absorb. Roughly 90% of the pre-existing Irish gene pool, the genetic signature of the Neolithic farmers who had built Newgrange and the other Great Passage tombs, was replaced. 90%. That is not a population drifting slowly over generations. That is a population being functionally overwritten in a handful of centuries. And the incoming DNA carried a very specific signature: heavy steppe ancestry, the genetic legacy of pastoralist groups that had migrated out of the Pontic-Caspian steppe region north of the Black Sea centuries earlier, moved westward across the European continent, and, critically, had spent significant time mixing with populations in Iberia before continuing on to Britain and Ireland. The people who arrived in Ireland with the bell beaker culture weren't coming directly from the steppe. They were coming, generations later, from the Atlantic edge of Iberia, carrying an Iberian filtered version of that ancestry with them. That is the signature the modern comparison keeps landing on. That is why, when Giampiero Cavalleri's Irish DNA Atlas team ran modern Irish genomes against ancestry panels covering the entire European continent, the closest genetic affinities outside the British Isles themselves consistently pointed toward the Iberian Peninsula, and within Iberia, most specifically toward the Basque region, a population famous among geneticists for having unusually deep, unusually undiluted roots of its own. Now, if you grew up with any exposure to Irish folklore, a bell should be going off right now, because this is not a new idea to Irish culture. It's an old one that modern people mostly forgot to take seriously. There's a medieval Irish text called the Labor Gabála Éireann, the Book of the Taking of Ireland, compiled by monks around the 11th century, but drawing on much older oral tradition. And it tells the story of successive waves of settlers arriving in Ireland. The final and most important wave, according to the text, were the Milesians, said to be the sons of a Gaelic warrior named Miel Espine, who is described as having sailed to Ireland directly from Iberia, from what the text places roughly in the region of modern Spain. For centuries, this was treated the way most origin myths are treated, as a piece of medieval storytelling, a flattering legend with no basis in fact, useful for a poem and nothing more. Nobody expected a Bronze Age population genetics paper to come along 1,000 years later. and land, broadly, in the same geographic neighborhood the monks had written down. To be clear, and this matters, the genetics does not prove the Milesian legend literally happened. Nobody is claiming a specific warrior named Miel actually led actual ships across the Bay of Biscay. What the DNA does show is that the deep ancestral roots of the population that came to dominate Ireland genetically, starting around 4,500 years ago, trace most closely, among all currently sequenced European populations, back toward the Atlantic Iberian coast. The myth and the data are pointing in roughly the same direction for entirely different reasons, one built from centuries of storytelling, one built from sequencing machines, and that convergence is what makes this finding land so differently than a normal ancestry statistic. If you've stuck with this so far, here's where things start layering. Because the story doesn't stop at one dramatic Bronze Age wave and one genetic answer copied and pasted into the modern population. Cavallari's team, when they finished comparing modern Irish samples to the rest of Europe, didn't just find one match. They found internal structure that nobody was expecting either. The Irish DNA Atlas identified something like 10 to 23 distinct genetic clusters within Ireland itself, subtly different regional populations, still measurably distinguishable from each other after thousands of years, corresponding surprisingly well to old medieval Irish kingdoms and border regions, boundaries that mostly stopped mattering politically centuries ago, but apparently never stopped mattering biologically. So the Irish DNA that keeps matching Iberia isn't one flat, uniform signal. It's a layered structure, an Iberian-rooted Bronze Age base with regional variation stacked on top of it. Variation shaped by everything from the later Norse settlements to the political boundaries of early medieval Gaelic Ireland. Let's take a second to restack what's been established. A near-total Bronze Age population turnover, an Iberian Atlantic genetic signature underneath the majority of modern Irish ancestry, a medieval legend that placed Irish origins in Iberia 1,000 years before anyone could test it, and a modern population still carrying internal regional divisions, old enough to predate the nation-state itself. If any one of those pieces stood alone, it would be an interesting footnote. Put together, they start to look like a single, continuous thread. There's also a question worth sitting with here, because it doesn't just apply to Ireland. If a Bronze Age beaker culture could move a population's genetic identity this dramatically in a matter of centuries, using nothing more advanced than boats and livestock, what does that say about how indigenous any European population actually is, once you look back far enough? The steppe ancestry that arrived in Ireland by way of Iberia is, at its root, the same broad genetic legacy that shows up, in different local flavors, across most of modern Europe, from Germany to Scandinavia to parts of the Italian peninsula. Ireland's version of that story simply happened to route through Iberia on the way in, which is why the Basque and Northern Iberian comparison lights up so specifically on the map when the researchers run the numbers, while comparisons to, say, populations further east or further north come back noticeably weaker. This is also where a second, quieter piece of confirmation comes in, because a single research group finding a pattern is interesting, but a pattern that shows up independently in a second, unrelated data set is what actually counts as scientific confirmation rather than a fluke of one study's sampling. Separate work using ancient genomes from Rathlin Island off the north coast of Ireland, dating to the Bronzes, aged and published by Cassidy's team, found the same underlying ancestry profile as the earlier Bell-Beaker period remains, meaning the Iberian-linked steppe signature wasn't a one-off result from a single burial site. It held up across multiple locations and multiple time periods within ancient Ireland, and separately again, broader European population genetics work, including studies out of the University of Copenhagen and collaborating institutions across the continent, mapping steppe ancestries spread westward through Iberia before reaching the British Isles, independently supports the same route, the same rough timeline, and the same general picture. 3 separate lines of evidence, 3 separate research efforts, landing on the same story. That is what triangulation looks like in genetics, and it's a large part of why this finding is held up rather than being quietly walked back the way a lot of flashier ancestry headlines eventually are. There's a 4th thread, too, and it comes from a completely different kind of marker than the ones we've been talking about so far. Most of what we've described up to now is autosomal ancestry, the broad genetic blend inherited from every branch of a family tree at once. But there's also the Y chromosome, passed down almost unchanged from father to son, generation after generation, and it tells its own version of this story. Ireland has one of the highest concentrations anywhere in Europe of a Y chromosome lineage called R1b, and within that lineage, a specific sub-branch that population geneticists trace back through exactly the same westward route, out of the steppe, through the European mainland, filtering through Iberia, and finally reaching the Atlantic edge of the British Isles. It's a slower, more conservative kind of evidence because it only follows one directive, paternal line at a time rather than a whole blended ancestry profile, but it independently lines up with everything the autosomal data and the ancient burial sites were already pointing toward. 4 separate methods, 4 separate data sets, 1 destination on the map. Before we get to what this all means, and before the story wraps back around to where it started, it's worth pausing here and being honest about the limits of what's actually being claimed, because this is exactly the kind of finding that gets exaggerated the moment it leaves a research paper and starts circulating online. Nobody sequenced Meal Espine. Nobody sequenced a specific Milesian king, a specific founding warrior, a specific named ancestor stepping off a specific boat in the Bronze Age. What has been sequenced and compared is population-level ancestry, the broad genetic signature shared by thousands of ordinary people living in Ireland and Iberia across multiple points in history, not the individual-level proof of any one legendary figure's existence or origin. That distinction matters enormously in genetics, and it's the distinction that separates a solid, published, peer-reviewed finding from an overreaching headline. The match between Irish and Basque or Northern Iberian populations is real. It's been replicated across separate studies, and it's a genuine, measurable genetic affinity, closer than Ireland's, matched to almost anywhere else in Europe outside the British Isles themselves. But it describes deep population history, a slow current running underneath centuries of separate local development, not a literal, one-to-one confirmation that the Book of Invasions is a factual travelogue. The Bell-Beaker migration itself is also not fully understood in every detail. Researchers are still working out exactly how the movement happened, how fast, and through exactly which coastal routes, and honest science leaves room for those details to shift as more ancient genomes get sequenced in the coming years. What doesn't shift, at least not with the current evidence, is the core shape of the story, a massive population turnover, an Iberian-rooted signature underneath it, and a genuine, if partial, resemblance between an old medieval legend and a 21st century genome comparison. It's also worth saying plainly that closest match is a relative measure, not an absolute one. Ireland's genetic affinity to the Basque country in northern Iberia is the strongest match found outside the British Isles. But it is not identical to it, and it doesn't mean the two populations are interchangeable today, 4,500 years and countless. Generations later, Iberia itself has continued changing since the Bronze Age, absorbing its own later migrations, its own later history, just as Ireland has. What the comparison captures is a shared deep root, not a frozen snapshot of two populations that stopped evolving the moment the Beaker culture arrived. Keeping that distinction honest is exactly what separates careful population genetics from the kind of ancestry test marketing that likes to promise more certainty than any genome can actually deliver. And that, in the end, is what makes this particular piece of research feel different from a routine ancestry statistic. Most of the time, science and old folklore run in completely separate directions, one steadily correcting the other, one gently retiring the myths that came before it. Here, for once, they're not fighting. A medieval Irish monk with no concept of DNA, writing down a story that had likely been passed by voice for generations before he ever picked up a pen, pointed toward Iberia. A 21st century population geneticist, running thousands of genome comparisons through software the monk couldn't have imagined, pointed toward roughly the same coastline. Nobody planned that convergence. Nobody could have faked it, because the legend was written down centuries before anyone had the tools to check it against a single strand of DNA. Maybe that's the real lesson sitting underneath all of this. Not that an old story turned out to be a literal transcript of history, but that a culture's deepest stories about where it comes from sometimes hold onto a thread of something real, folded into the poetry, long after everyone stopped expecting it to be checkable at all. So tell us in the comments, which part actually caught you off guard? The idea that 90% of ancient Ireland's population was replaced in a matter of centuries, or the fact that a 1,000-year-old legend happened to point toward the same coastline the genome data eventually confirmed? And if this is the kind of story you want more of, ancient DNA quietly rewriting what we thought we knew, make sure you're subscribed, because this is far from the only bloodline the data has something to say about. There are other islands, other legends, other genomes sitting in freezers right now waiting for someone to run the comparison, and every one of them carries the same basic possibility, that a story dismissed as folklore for 1,000 years might simply have been waiting for the right machine to check it.